Meet Jane. Jane is the marketing manager at buyourstuff.com, an online retailing business. Jane has a problem. The business is experiencing significant customer churn, meaning customers aren't coming back to their website. Jane's boss has given her the task of reducing customer churn by 20%. No problem, says Jane. My marketing team has a great incentive for customers, but we need to target those customers who are most likely to churn because we can't afford to offer the incentive to everyone. Jane is a smart marketer and knows from experience that better analytics will help her achieve her goal. She identifies a need for a predictive model to find out which customers might churn before they actually do. Jane has historical data for all customers, including ones who have already churned, and she wonders if she can use those data to build a model that can predict future churners. Lucky for Jane, her company uses SAP Predictive Analytics, which will make her task quick and easy. Jane opens SAP Predictive Analytics and selects Modeler under Automated Analytics. She then selects Create a Classification Regression Model, chooses her input data file, and then clicks Next. In the data description screen, she clicks the Analyze button so the software can identify the type of data in each variable. She then takes a look at the data to make sure it has been imported correctly. In the next screen, Jane selects the variables she wants to include in her model. The target variable she wants to predict is called churned, and all the other variables in her data appear as explanatory variables. On the summary screen, Jane accepts the default settings and then clicks the Generate button. The software uses an intelligent process to build and compare many different models until it finds the best one possible. On the Model Overview screen, Jane can see some summary information about her model, but she is most interested in the predictive power and the prediction confidence. A predictive power between 0.6 and 0.9 indicates the model is good to excellent. The prediction confidence is a measure of how consistently the model performs across different datasets. The software automatically splits the data into 3 random subsets. It uses the first of these to build the model, and then it uses the other 2 subsets to test the performance of the model. A prediction confidence very close to 1 means the model performs almost identically across the 3 different datasets. This gives Jane confidence that when she uses this model to score her current customers, she can expect similar results to what she sees here. However, the most important question for Jane is how profitable will her campaign be? First, Jane knows that the customer incentive will cost her business $10 for every customer who receives the offer. She also knows that every customer who accepts the offer will return an average profit of $60. With this information in hand, Jane can answer her question quickly and easily with the Cost Matrix feature available from the Confusion Matrix screen. In the Cost Matrix box, Jane enters 60 in the top left cell and minus 10 in the bottom left cell. The top left cell represents customers the model correctly identified as churners, while the bottom left cell represents customers who would not have churned, but who the model predicted would. These customers end up receiving the offer even though they would have stayed without it. Jane then enters the total number of customers she currently has in her database in the box labeled Total Population. She then clicks the Maximize Profit button. The software calculates how much profit she can expect from her campaign if all the customers predicted to be churners accept her offer. She can now see that if she targets only those customers, she can expect a profit of $40,000. She can also see that if she randomly selected customers instead of the ones the model identified, then she would expect only $8,400 in profit. Jane is now confident that her promotion will be profitable if she only targets the customers the model has identified. The last thing Jane needs to do is export her finished model so her database team can load it into the customer database and use it to identify all the customers who will receive the new offer. To do this, Jane selects Save and Export, then Generate Source Code. She selects the database language she wants to use and the file she wants to save it to. She then takes a quick look at the generated code before emailing it to her database team. And that's it. Jane's built and tested a model and deployed it into a database. Jane loves SAP Predictive Analytics because it empowers her to build and deploy predictive models she can trust in no time at all. The solution is designed to build these types of models quickly, easily, and reliably. In fact, all of Jane's friends at buyourstuff.com love SAP Predictive Analytics because it empowers them to achieve their goals too, just like Jane.